Hello everyone, welcome to Kamaraj College of Engineering and Technology YouTube channel. I am Dr. T. Dhanlakshmi from Department of Chemistry. In this video, we are going to discuss about boiler corrosion. It is comes under one of the troubles that is created when hot water is used in the boilers. So normally we know what is corrosion. Corrosion is the decay or disintegration of the surface of the metal by chemical or electrochemical attack. Here also the boiler that is made of steel will be corroded by either dissolved oxygen or carbon dioxide or salts present in the water. This is what we are going to see now and how these salts can be easily removed. First, boiler corrosion is decay of boiler material by chemical or electrochemical attack by the environment. Main reasons are dissolved oxygen. Normally water contains 8 ppm of oxygen, dissolved carbon dioxide and dissolved salts. So, if these are present in even minute quantities, it results in the corrosion of the boiler material. We are going to see one by one how this reacts. So, first dissolved oxygen. So, water usually contains 8 ml of dissolved oxygen per liter at room temperature. So, this is what that is needed for the fishes to survive in the water. So, if this dissolved oxygen in water attacks the boiler material at higher temperature. So, when water is boiling, this dissolved oxygen attacks the boiler material. So, actually iron will be reacting with the oxygen to form ferrous hydroxide. So, this ultimately in the presence of excess oxygen results in the formation of rust. So, the boiler material gets rusted. So, how this dissolved oxygen is removed? So, this is removed by two methods. First one is chemical method and the second one is mechanical methods. So, let us see first chemical methods. So, here we will be adding some compounds like sodium sulfide, hydrazine. So, they will absorb oxygen and form new salts even in the water. So, Na2SO3, that is sodium sulfate, with the oxygen it gives sodium sulfate. Otherwise, hydrazine, that is N2H4 plus O2 gives N2 plus 2H2O. These are the chemical methods. The best one is hydrazine, because hydrazine when treated with oxygen, it results in the formation of inert N2 gas and water itself is the byproduct. So, nitrogen will be sent out. So, hydrazine is the best method. Next, mechanical deaeration. Here for this we will be having a setup. So, you can see this setup. It is a long tower. The tower it is connected with a vacuum pump and outside it will have a steam jacket. So, we will be having high temperature and pressure. So, when water is fed from the top side and when the water is fed inside, it is spread out. So, when you spread out at the same time, when you have high temperature and pressure, dissolved oxygen is removed. So, this by mechanical deaeration, water is allowed to fall slowly on the perforated plates fitted inside the tower. The sides of the tower are heated and it is also connected with a vacuum pump. So, the high temperature, low pressure and large exposed area removes dissolved oxygen. So, next dissolved carbon dioxide. Normally carbon dioxide reacts with water to form carbonic acids. So, this carbonic acid is a mild corrosive agent. So, CO2 plus H2O gives H2CO3. So, this carbon dioxide is also produced by decomposition of calcium bicarbonate. So, when you have not properly softened the water, these salts may be present. At high temperature, they will decompose to give calcium carbonate and carbon dioxide. This carbon dioxide can react with water to give carbonic acid. This is a corrosive agent. So, how dissolved carbon dioxide is removed? This is also removed by mechanical deaeration or chemical addition. So, first removal of carbon dioxide, it can be done by adding ammonium hydroxide. So, ammonium hydroxide reacts with carbon dioxide to form ammonium carbonate and water. This is one step, that is by addition of some chemicals, and second one, it is also removed along with the dissolved oxygen by mechanical deaeration method. So, in the mechanical deaeration method, we can remove both carbon dioxide as well as oxygen. Next, dissolved salts. Actually, the hot water usually contains calcium magnesium salts in the form of chloride or carbonate or sulfates like that. So, when they are in the boilers, they form repeatedly acids by hydrolysis. So, this acid cannot be removed easily. As such, we can see this from these equations. Acids produced from salts dissolved in water also mainly responsible for the corrosion of boilers. Salts like magnesium chloride, calcium chloride, they hydrolyze, so they result in calcium hydroxide and magnesium hydroxide as well as HCl. So, this HCl, it is also a corrosive agent, it destructs the boiler material. So, for example, MgCl2 plus 2H2O gives MgOH twice plus 2HCl. Otherwise, iron Fe plus 2HCl gives FeCl2 plus hydrogen. So, this acid formed reacts with the iron of the boiler material, and this reaction continues again because FeCl2 further reacts with water to give Fe hydroxide and 2HCl. So, this HCl is produced continuously in the boiler. So, this can be removed only by adding some alkaline material like NaOH, but anyway the sodium hydroxide will also result in caustic embrittlement. So, this is a continuous process. So, effective softening must be done to remove all these salts so that boiler corrosion can be minimized. Thank you.